Welcome back to Djji Tutorials. Let's dive into factoring using the substitution method and the greatest common factor. To factor an expression of the form a of x plus b of x plus c where a is not equal to 0 using substitution, follow these steps. Step-by-step process. 1. Let u equal fx. This substitution simplifies the expression a of x plus b of x plus c becomes au2 plus bu plus c. 2. Factor the quadratic in u. Now factor au2 plus bu plus c using any preferred factoring method, trial and error, AC method, or quadratic formula if necessary. 3. Substitute fx back in for u. Once factored in terms of u, replace u with fx. Example, factor 2 times 3x plus 1 squared plus 5 times 3x plus 1 plus 3. Step 1, let u equal 3x plus 1. Now we have 2u squared plus 5u plus 3. Step 2, factor 2u squared plus 5u plus 3. Try factoring 2u squared plus 5u plus 3 equals 2u plus 3 times u plus 1. Step 3, substitute back u equals 3x plus 1. Final answer, 2 times 3x plus 1 plus 3 times 3x plus 1 equals 6x plus 2 plus 3 times 3x plus 1 equals 6x plus 5 times 3x plus 2. Let's factor the expression x minus 3 squared plus 14 times x minus 3 plus 40 using substitution. So step 1, let u equal x minus 3. The expression then becomes u squared plus 14u plus 40. Now step 2, we need to factor the quadratic in u. We need two numbers that multiply to 40 and add to 14, which are 10 and 4. So, u squared plus 14u plus 40 equals u plus 10 times u plus 4. Finally, step 3, substitute back u equals x minus 3. The final answer is x minus 3 plus 10 times x minus 3 plus 4, which simplifies to x plus 7 times x plus 1. So the factored form is x plus 7 times x plus 1. To factor an expression of the form a squared times f of x squared minus b squared times g of y squared, where a is not 0 and b is not 0, you're dealing with a difference of squares. The general identity for the difference of squares is a squared minus b squared equals a minus b times a plus b. Alright, let's go through the step-by-step process. First, recognize the structure. Let a equal a times f of x and b equal b times g of y. Then a squared times f of x squared minus b squared times g of y squared becomes a times f of x squared minus b times g of y squared. Next, apply the identity. So, a times f of x squared minus b times g of y squared equals a times f of x minus b times g of y times a times f of x plus b times g of y. Final factored form, a squared times f of x squared minus b squared times g of y squared equals, well, a times f of x minus b times g of y times a times f of x plus b times g of y. Example, factor 9 times x plus 1 squared minus 4 times y minus 2 squared. Step 1, recognize it as a difference of squares. Here a equals 3 and f of x equals x plus 1, b equals 2 and g of y equals y minus 2. So 9 times x plus 1 squared minus 4 times y minus 2 squared equals 3 times x plus 1 squared minus 2 times y minus 2 squared. Step 2, apply the identity. This equals 3 times x plus 1 minus 2 times y minus 2 times 3 times x plus 1 plus 2 times y minus 2. You can leave it factored like that or simplify further. This equals 3x plus 3 minus 2y plus 4 times 3x plus 3 plus 2y minus 4. Which simplifies to 3x minus 2y plus 7 times 3x plus 2y minus 1. To factor an expression of the form a squared times f of x squared minus b squared times g of y squared, where a is not 0 and b is not 0, using the greatest common factor method, follow these steps. Alright, let's dive into the step-by-step guide using the GCF method. First, check for a GCF in the entire expression. Look for any common factors in both terms, like a squared times f of x squared and b squared times g of y squared. If there is a common numerical or variable factor, make sure to factor it out first. For example, if a squared and b squared share a GCF, like a number or a variable, go ahead and factor it out. Next, apply the difference of squares identity. Once the GCF is factored out, if any, you're left with the difference of squares, which factors as a squared minus b squared equals a minus b times a plus b. General factoring formula. If there's no GCF, then a squared times f of x squared minus b squared times g of y squared equals a times f of x minus b times g of y, all multiplied by a times f of x plus b times g of y. If there's a GCFD, then d times a prime times f of x squared minus d times b prime times g of y squared equals d times the quantity of a prime times f of x squared minus b prime times g of y squared. Then factor the inner difference of squares. Example 1. No GCF. Factor 16 times the quantity of x minus 1 squared minus 9 times the quantity of y plus 2 squared. No GCF, so apply difference of squares directly, equals 4 times the quantity of x minus 1 minus 3 times the quantity of I plus 2, all multiplied by 4 times the quantity of x minus 1 plus 3 times the quantity of I plus 2. Example 2, with GCF. Factor 4 times the quantity of x plus 2 squared minus 4 times the quantity of y minus 5 squared. Here, GCF equals 4, so we get 4 times the quantity of x plus 2 squared minus y minus 5 squared. Now factor the difference of squares inside, equals 4 times the quantity of x plus 2 minus y minus 5, all multiplied by x plus 2 plus y minus 5. Simplify, equals 4 times the quantity of x minus y plus 7, all multiplied by x plus y minus 3. Conclusion. First, factor out any GCF, whether it's numbers, variables, or expressions. Second, use the difference of squares identity to factor what's left. Third, simplify if needed. We hope you find this video useful. Please share with your classmates and let us learn together.